Hello everyone. So really sorry for the previous contest solution was not uploaded. We'll try to upload this. Really sorry. Let's start with the problem statement. The problem goes by the name subsequence after one replacement. Right. This is the second problem of this contest, and it is a very beautiful suffix and prefix concept problem. You can solve it using DP. There are much pruning needed to it that can't be solved using the basic DP thing. I will explain the DP solution as well, but let's first read the problem statement and try to understand what the problem is saying, right? So the problem says that you are given two strings S and T consisting of lowercase English letters. You may choose at most one index in S and replace the character at that index with any lowercase English letter. You need to return true if it's possible to make S a subsequence of T. Otherwise, you need to return a false, right? Now let's look at a test case. The first test case is cat and chat, right? Uh, so the first case is cat and S is cat and T is chat, right? Now you need a subsequence in T means you can delete any number of characters from any place, and that S, let's call that as, for a now let's call that as alpha. This S should be equal to alpha, right? But one more catch is there, that you can replace any character in S as well to anything of that you want, right? Let's say your alpha is C HT, right? And your S was CAT, right? So now you can convert this A into H, and now see S and alpha are equal, right? Alpha could have been CAT as well, and now your S can be C, and your S was CAT, and this is also a valid sequence, so you can return true in this test case, right? If you look in the other test case, the other test case is plain and apple, and by performing any number of operations you can't reach to that test case, right? So this is very obvious, right? You can't delete any character and reach to apple, right? So the main constraint of the problem was 1e5, right? Your n and t m, right, which is the length s dot length and t dot length, right? This both were till 1e5 means 10 to the power 5. And now you need to write a solution which will take at least big O of n or big O of n log n time, right? And the DP solution which you might have thought, right? If you know a bit of basic DP, the thought is, let's say you had a S of string, let's say A, B, C, D, E, and let's say your string D was, let's say, let's take anything, right? A, B, F, D, M, E, H, G, anything, right? So if you look in this, right, the two DP states could be that I can start with this I can have this index as J here, right? And I will have one chance of replacement, right? One chance of replacement. I won't be exploring this case because this the case that the code which I wrote in DP definitely got a TLE, right? And why so? Because see, what are the changing states? I is a changing state, J is a changing state, and chance of replacement that could be either 0 or 1. So it is also of two size, right? So the solve function which I would have written must have the changes as dp of I, j, and let's call this as change, right? So this would have been my dp state, right? dp of I, j, and changes, right? And this could go till 1e5, right? Means 10 to the power 5. This can go till 10 to the power 5 and 2, right? So ultimately it is 10 to the power 10 according to my DP states, and that caused a TLE, right? I'm pretty sure that could be this time complexity could have been pruned a lot, right? Means you could have saved your states somehow and reduce this as dp of index and chances as well, but I couldn't think of that in that way, so I came up with a greedy solution, right? Now let's look at the greedy solution and how could we solve it, right? A very prominent solution which you could use in future as well, right? So let's first look let's take a random test case, right, so that you can understand it, right? Let's take, I had A, D, B, F, C, and this was my string S, right? And my string T, let me write this on this side, right? Let's call this as S, and let's say we had a T, let's say this as K, L, M, and let's check A, then let's say P, P, then let's check D, then let's say we don't have a character B only, right? Let's take again P, P, then take F, then again P, P, and then C, right? My thought process of this solving this problem is a quite different, right? How is it different is, let's say I want to replace this character, right? Let's say I want to replace, let me color it with the red one, right? Let's say I want to replace this character, right? Now in order to replace this character means I can replace it with any character of my choice, right? What I'm trying to say, if I want to replace this character, now I want to find where is the earliest index in my T where I could have A and D both, right? Not together, but it should be there, right? Means A should come first, then D should come, right? What is the, let me write it. What is the earliest index where I could have AD together, not together, AD, right? So if you look, I can call this as prefix, right? You can name it as any way. I am calling it as prefix. What does prefix of I mean? Prefix of I means what is the earliest point if I want to find this index. Like if I'm at, let's say I want to replace this B, then what is the earliest point where I could have AD? This would be stored in my prefix, right? And we will have a suffix as well, right? What is suffix? Suffix of I, suffix of I will be, let's say if I'm at this B, I will say suffix of I means what is the earliest point, right, where I could have FC in my substring from the end, from the very end. What is the earliest point where I could have F and C, right? So we will do a dry run on the same test case, right? Let me I think you have understood what is the meaning of these 2 points, these two terms which I will be using, right? Now let's quickly write this test case again. It is ADBFC, right? And it is let me write with green, right? Second is KLMA, PPA, PPD, PPF, PPC, right? Now see how what we will do. I want to find what is the, let's take a cool color, let's take orange, right? Let's say if I'm at this A, what is the earliest point I can have a A? Is how will we do that? We will place a pointer I at this point, G at this point. If it matches, I will say, hey, this is the earliest point where I could have a A, right? So what is the earliest point we could have a A? Yeah, you got a A. So you will write prefix of I will be equal to, or rather prefix of I plus 1, because why I plus 1? Because while if you have done a bit of problems on prefix, you would have noticed that prefix generally go out of bound if you don't handle the indices properly, right? So we will write prefix of I plus 1. I will explain it why as well. So as of now, just trust me and say that, okay, whenever we are writing prefix, we will say prefix of I plus 1, right? What is the earliest point you got this A? That is at this index, which was index 0, 1, 2, 3. Okay, now let's go to D, right? What is the prefix of AD? Means where you found A at 3. Now just need to find this D, where you find the first D after this A, right? So you will continue from this point only, right? You will go to P. It is not a D. Is this a D? No, it is not a D. This is a D. So prefix of, let's write it as 1, right? Prefix of 2 will be equal to 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Okay, wait a second. Yep. So prefix of 2 will be equal to 6. Okay, let's find this B. Could you find B in this array, in this string? No. So prefix of this b, which is 3, will be infinity, right? If you couldn't find this b, there's no point of finding anything further than fc in prefix, because hey, you can't have this adb in your substring as a subsequence in t. How could you have adbf in your subsequence, right? So everything except for that value will be infinity, means prefix of 4 will be infinity, prefix of 5 will be infinity as well. Am I making sense to you? Right? What does the prefix of 4 means? This prefix of 4 means you want to find adbf, adbf, adbf. Did you get a adbf in your substring as a subsequence in t? No, you didn't, right? So that is why the answer at that point is infinity, right? Let's quickly look at the suffix array, right? Suffix of, you will start with n minus 1, right? So suffix of n minus 1, you will start with this point and this index at this. Oh, hey, you got a forced equalizer. So you will say suffix of n minus 1 is 12, right? Suffix of n minus 2, n is, let's say, 0 1 2 3 4, right? So suffix 0 1 2 3 4, yeah. So suffix of 4 you can write as 12, right? Suffix of 3 means where you will find c and f, right? You found the c here, you go on, oh hey, there is the f. So cf could be found at 9, right? Let's look at c suffix of 2, right? You will try to find c suffix of 2 means bfc will be somewhere in the subsequence, right? In the t, starting from the end. You found this c here, you found this f here. Now you will try to find b and you wouldn't get it. This will lead to infinity. Infinity for 1 and infinity for 0 as well, right? So this is your suffix and prefix table created for you. Yes or no? Now you will say, hey, even if I calculated that, what is the advantage of doing that, right? Okay. I guess this place is a bit dirty for you, me to explain this, right? So I need to again write this test case ADBFC. Let me quickly write it, and KLM and APPD, then I guess double PF, double PF, and then double PC, right? Great. Now I guess it is clear. Now you saw that there was no point of having this B, right? So what I can say is, hey, what is the earliest point I could have AD? You will say ask in prefix of 0 1 2, right? So prefix of 3 will give you the answer. Why? Because you don't want, see, at one point you will have a prefix of 0 as well, right? Wait a second. Yeah, so you will have a prefix of 0 as well. So at that point you don't want to go beyond, means you want to delete this element, right? You say, hey, I won't need this element. Tell me, before this element, what was the previous index, right? How many, which was the earliest in my t, if I wanted to replace this character, right? At that point you might go out of bound. Yes or no? Because if you do 0 0 minus 1 to get the previous elements answer in prefix, you will be at wrong index, right? So that is the reason I am doing prefix of I. I had did prefix of I plus 1, right, at early phase, right? So when I'm at index B, I will simply ask, hey, what is the earliest, what is, it will be 2 not 3, what is the earliest point I could have AD, which is prefix of 2 in my answer. You will search it in big of 1 because you have created that table. Yes or no? So you will look at prefix of 2. Prefix of 2 represents 6. Yes or no? So look at your T. Wouldn't you get a AD till index 6 only? Yes or no? You will say, wow, that is crazy. So if I want to delete, you saw that without replacing the character B, answer won't be possible, right? So when I'm at B, I will say, hey, I will traverse on all elements, right? I'm not saying that I will not, in my code I won't be traversing, but now it is not possible for me to explain every cases. I will explain it to you for another case, like for I will do it for D. But first understand what, because you have seen that, hey, I need to replace this B anyway, right? So let's see what is the advantage of replacing this B, right? So when you want to replace this B, you will ask prefix of 2. Prefix of 2 gives you an answer of 6, right? Means you can replace this, but the earliest where you can have a subsequence AD is at index 6, right? I will say okay, you will see a logical thing here, right? Now I will say, hey, suffix of it is index 2, you need to find till fc, right? So you will say index plus 1, which is 2 plus 1, which is 3. So suffix of 3 will give you your answer. You will go look at suffix 3, it is 9, right? What does this mean? This means that to get a fc, the earliest from the end that you can have is this point, and the earliest you can have ad at this point, right? Now you see, this was 9, this was 6, the difference is 9 minus 6, which is 3, right? Means in between of them there are 3 indices. I don't think there are 3 indices. Why is this 3? 6 7 8 9. So 9 minus 6, yeah, which is 3, which means there would have been 3 elements, but how many places are there? There are definitely 2 places, right? 2 places. So what I can say is, let's call this as b, let's call this as a. If my b minus a is greater than 1, right, as you can see 3, that means there is at least some place in t which could be matched with this b, right? Because see, here it was b, right? You could convert this into p, right? But for that you need to have some elements in between of them so that you can replace it. Yes or no? Am I making sense to you? Right? What I'm trying to say is, let's say your index ended at this point, right? Your which was if I'm not wrong, it was d, right? So d ended at this point and fc ended at this point, right? So in between, if you have at least one element, right, let's call this as z, then you could have converted this b into a z and your answer would be true, right? Because yeah, hey, I found a subsequence, right? But what if this position would have, like, let's say uh, the d would have been at d would have been come at this position, and the f which we had came at this position, right? Let's call this 10, let's call this 6, right? Now could you place any element in between? No, because d needs to go till this point, f needs to come till this point. So there is no point of having this as a valid solution, so you can't return a true here, right? I hope the suffix and prefix logic made sense to you, right? Let's look at a test case so that we can understand that as well, right? Uh, let's take this case, right? Plain and apple. Let's quickly look at this, right? So plain and apple, right? So prefix of p will be found at this index, prefix of 1 will be at index 1, prefix of 2 will be at index l, will be at index 0 1 2 3 4. I think you are doing also dry run with me, right? So prefix of 3, that is getting a is infinity, and so on and so forth, every value will be infinity, right? Let's quickly look at suffix, right? So suffix of let's call this 4, so e will be at index 4 only, will be at index 1, right? That is suffix of 3 will be 1, and p will be at index 0, suffix of 2 will be at 0, suffix of 1 will be at p out of 1, so that means you will write infinity at those points, right? Now you can try any possible combinations, and you see 1 and 4, right? When you do, sorry, 1, prefix of 1 is 1 and suffix of 1 is infinity, so this won't be a valid condition. Prefix of 2 is 3, suffix of 2 plus 1, which is 3, is this, right? So prefix of 3 goes till value 3 and suffix comes till value 1. Are you seeing what is happening? See, prefix of 2, which means 0 1 2 3 4, so till 1, right? So for this one index you need to go to this point, right? And let's say you want to delete this a, then this n, then this n won't be possible, right? But let's say this a comes at this index, right? So this l will have to go till this point, this a will have to come till this point. How is it that possible? You can't create a subsequence like that, right? So for that reason you will return a false. The only valid possible is if your prefix ends at an index I and your suffix end at an index j, and j minus I is greater than 1. I hope j minus I is greater than 1 is valid for you. Let's say it was 5, let's say it is 6, And if j is at this point, I is at this point, then there is no element in between where which could be replaced, right? Let's say this was a, this was, there is no element here which could have been replaced with that, right? So I hope I made sense to you, right? That the difference should, why should difference should be greater than 1, because 6 minus 5 is 1, right? So but there is no character in between that could have been replaced, so that is why the answer should be greater than 1, right? So that is it, that is the whole logic for the problem. I hope the logic is clear to you. Let's quickly look at a test case, right? I have written the db state as well. I will place the code in the description as well. This is a db code, this will give you a tle, right? Now let's look at the code which will actually pass, right? You give me a second. Yep. Okay, so what I did, I was first I created a prefix end, right? And prefix end of 0 is -1, because I have explained you why, because you don't want to go out of bound, right? Now you start I with 0, j as 0 if I is less than equal to n and j is less than m. If suffix of I is equal to t of j, you simply say prefix of end I plus 1 is equal to j and you do I plus plus, right? Else you do a j plus plus, right? J++ is done in every cases, right? Because you want to keep moving forward, right? Similarly, you have a suffix of start, right? You will create a suffix of start that will start from n minus 1 and m minus 1 and do the following thing as we did. Suffix of start of j, I will be equal to j if the element matches, right? Now you will start from k equal to 0 to k less than n, right? Left bound means what happens if I delete this or I want to replace this character? What is the prefix end value of k? Right, prefix end will store a value of k, a value, right? Similarly, right bound will store the suffix of start k plus 1. Means let's leave this index. What is the earliest point the index I plus 1 can have, right, in the substring t, right? If my left bound is not equal to 199 and my right bound is also equal to minus 199, right, and my right bound minus my left bound is greater than 1, then I can return a true. And if I haven't returned a true in any of the cases, then I need to return a false, right? I hope the logic was clear to you. The space time complexity is big of n, whereas the space complexity is big of n plus big of n, right? Which is ultimately big of n only, right? So these are completely under the bounds and it will get accepted as well, right? So I hope I was able to explain the problem statement to you and the solution was clear to you as well. If yes, please do give a comment, give a beautiful comment, leave a beautiful comment and give likes. Do subscribe and share as well. Thanks for watching. Let's meet in the next one. Thanks for watching again and do subscribe.